So our question is, we are given a graph and we have to find the vertex connectivity for this graph. So first of all, what is the vertex connectivity? So the vertex connectivity of a graph G is denoted by Kg as the minimum number of vertex in a vertex cut. Okay, so what we have to do, we have to find out the vertex cut now. Okay, so let's see what is the vertex cut. Vertex cut is a set of minimum vertices whose removal leaves our graph G disconnected. Okay, so what we have to do, we have to find out a set of vertices which is the minimum, so that if we remove those vertices from our graph, it should leave our graph G disconnected. Okay, what do you mean by the graph G goes disconnected? It means that we have more than one partition in our graph, so that there exists no single edge between those partition components. Okay, so how do we find out the graph or how do we remove the vertices from any graph? So let's say we have this graph A. Suppose we have this graph towards ABCD, and we have this graph E. Okay, now what we have to do, we have to find out the vertex cut of this graph. So to find out the vertex cut of this graph, what we have to do, we have to find out such minimum number of vertices whose removal will leave this graph disconnected. So what we have to do, let's say we are removing B. So to remove B, what we have to do, we have to delete all the edges which are connected to B. So means we have to remove this edge, we have to remove this edge, we have to remove this edge, and we have to remove this edge. So what is my remaining graph? My remaining graph is this only. Is this graph disconnected? No, because we still have only one component. This area is now deleted. We have removed this area from our graph. So we still have only one thing left. So what we can do, we'll draw the leftover part, that is A, C, D, and E. So let's remove D. What we have to do, let's remove D. So removal of D will disconnect these edges also. Now let's see what is left to us. Now we are left only with AC and E here. So now my graph is disconnected. One portion is this, one portion is this. So the vertex cut of this graph is B and D. Okay, so likewise we have to find out for our this graph. So let's see what will be the one of the vertex cut is BC and let's see my B will if I disconnect B, if I disconnect C, if I disconnect F, will leave my graph in a disconnected position. So the vertex connectivity of this thing is 3. And do remember minimum number of vertices should be taken.